Good morning, everyone, and welcome to our webinar. Thank you for joining us today. My name is Marcin Woch, and I am the CEO of Algorithmics Technologies. During this session, we will talk about how companies can use their own first-party customer data to build real-time profiles, personalize communication, and automate marketing decisions with machine learning. The main topic of today's webinar is the use of Algorithmics Event Engine as a real-time feature store and DMP platform, a platform that can collect customer events, transform them into profiles and features, and make them available for personalization, scoring, recommendation, and automated campaign decisions. Before we start, just a short organizational note. During the webinar, you can write questions in the chat. We will try to answer selected questions during the presentation, and we will also leave some time at the end for Q&A session. So let's begin. Before we go deeper into Event Engine, let me briefly introduce Algorithmics and our technology platform. Algorithmics is a technology company focused on data science, machine learning, data quality, scoring, and decision automation. Our platform is designed to help organizations build, deploy, and operationalize machine learning and AI solution in production, from data preparation and enrichment through model development to real-time scoring and decisioning. The platform consists of several components: data quality support, data standardization, enrichment with geocoding and location intelligence, advanced miner and APM supports, data exploration, feature engineering, and automated model training, and scoring one is responsible for model lifecycle management, decision automation, and production deployment. Event Engine, which is the main topic of today's webinar, is an important part of this ecosystem. It acts as a real-time feature store and event processing layer. It allows companies to collect behavioral events, build customer profiles, calculate features, trigger machine learning models, and expose profiles and scores through APIs. So today we will focus on Event Engine, but it is worth remembering that it is part of broader end-to-end data science and machine learning platform. So let's answer the key question: why first-party data is now a key marketing asset. For many years, digital marketing relied heavily on external identifiers, third-party cookies, and data available through advertising platforms. This model is becoming less stable. Even if third-party cookies do not disappear overnight, companies can no longer treat external tracking signals as a fully reliable foundation for long-term marketing strategy. Browser restrictions, consent requirements, privacy regulations, and platform policies are all reducing the availability and quality of third-party data. At the same time, large digital ecosystems increasingly operate as wallet gardeners. Search platforms, social networks, marketplaces, or large publishers or advertising platforms provide rich and targeting capabilities, but they also control access to user-level data. Brands can activate campaigns inside these environments, but they often cannot fully own, analyze, or reuse the underlying customer intelligence outside the platform. This is why first-party data has become a strategic marketing asset. It gives companies direct control over what they know about their customers. The value is not only in collecting this data, but in transforming it into customer profiles, predictive features, and automated decisions. There is also a second important business goal, especially for e-commerce platforms, marketplaces, publishers, and retailers with online traffic. First-party data can become a direct revenues asset. Companies do not only have to sell products and services, They can also offer producers, brands, and suppliers the ability to promote their products through well-targeted advertising placements on their own digital properties. This is where a modern DMP becomes more than a marketing database. It becomes a customer intelligence layer, a real-time feature store, and decisioning engine. It supports personalization, segmentation, recommendations, and expects action algorithms and advertising monetization. The key point is that first-party data creates value only when it can be activated quickly. The customer is active now, the session is happening now, and the opportunity to personalize and show the right advertisement may last only a few seconds. The winners will be the companies that can turn their own data into real-time profiles, predictive features, personalization, or new advertising revenue stream. A useful way to understand a DMP is to think of it as the layer between raw customer data and marketing actions. Most companies already have a lot of customer-related data, but it is often fragmented. On their own, these data sources are available, but they do not automatically create customer intelligence. This is where a DMP comes in. Its role is to collect and organize these signals, connect them to the customer or profile layer, and transform them into something that marketing team can actually use. At the input level, the DMP receives data from many sources. Inside the platform, several things happen. First, events are collected and normalized, then identifiers are connected so that data points can be assigned to the same customer, cookie, user, household, where possible. Based on this, the platform builds profiles. These profiles can contain behavioral features such as number of visits, recent product views, purchase recency, category interest on promotion, responsiveness. Once profiles exist, the DMP can group users into audiences or segments. It can also enrich the profiles with predictive scores. For example, likelihood to convert, churn risk, next best product, or probability of response to a specific campaign. The final step is activation. This is where the DMP starts helping marketing directly. The resulting profiles and segments can be sent to personalization engines. In a more advanced setup, they can also be exposed through APIs and used in real time. How to take back control of your data. This is important thing, how to start with it. When we talk about taking back control of data and campaigns, we do not mean replacing every advertising platform or marketing tool you have. These platforms will still be important. The point is different. Companies should not depend entirely on external ecosystems to understand their own customers and decide how to communicate with them. The first step is to collect your own behavioral signals as a first-party data. Instead of treating these data points as isolated reports in separate tools, they should become part of the one unified customer intelligence layer. The second step is profile building. A modern marketing platform needs to connect events to users, customers, sessions, devices, or accounts. The goal is to create profiles that are not just static records, but dynamic representation of customer behavior and intent. The third step is to create your own features, segments, scores, and rules. This is very important shift. Instead of relying only on segments defined inside advertising platforms, companies can definitely define their own business logic. The fourth step is activation. Once profiles and scores are available, they can be used across many channels. The final step is learning. It is important step. Every campaign, click, conversion, purchase, or non-response event should feed back into the system. This allows the company to improve its profiles, update features, retrain models, refine segments, and optimize marketing decision over time. So this is simple learning rule that should be implemented in the tool. This is exactly the role of the modern DMP or event engine-based architecture. It gives marketing teams and data team common layer for real-time customer intelligence and campaigning decision. So next, go further. Look. But in practice, building DMP from the scratch is a very hard task. It sounds simple at the beginning, and easy, collect events, sort them, build profiles, and use these profiles in campaigns. But in practice, this quickly becomes a complex real-time data and machine learning engineering project. The first challenge is the event volume. A digital business can generate a huge number of behavioral events. These events need to be collected, processed, and assigned to the right user, session, device, account, or customer profile. The second challenge is freshness. In marketing, timing matters. If a customer is currently browsing a product category, abandoning a basket, or reacting to a campaign, the profile should be updated immediately. The value of the signal decreases very quickly if it is processed hours later. The third challenge is latency. A DMP should not only store profiles, it should also serve them quickly, so access should be also on time. Successful marketing action may need an answer why the customer is still active, still on process. That means the profile has to be available over an API with very low response time. The fourth challenge is consistency between online and offline processing. We will describe what it means further. But data team often creates features on historical data. This is the offline mode for model training. And then engineering teams re-implement similar logic for production scoring. This online mode. This creates duplicated work and major risk that the future features used to train model may not be exactly the same as the feature used in real-time scoring. This is one of the most common problems in production ML machine learning system. The fifth challenge is flexibility. Marketing and analytics team need to test new segments, change time windows, define new behavioral features, and deploy new models. If every change requires a cool custom engineering project, the problem becomes the platform or the whole system becomes too slow for business needs. This is where hyperscaler-based architecture become tricky. You can think that cloud providers offer excellent services for streaming, storage, processing, machine learning, APIs building, and monitoring. But these services are usually generic building blocks. They do not automatically create a complete working DMP. You still need to design the architecture, integrate the services, define the custom profile logic, manage feature definition, handle real-time serving, monitoring of pipelines, control costs, and connect everything to marketing activation channels. So the main risk is not that the technology will be impossible to build. You can also, of course, build everything from the scratch. The risk is that the solution is too complex, too expensive, too engineering heavy, and too slow to support day-to-day marketing activities. This is why, when evaluating a DMP architecture, it is important to ask practical questions. Can we define a feature once and use it both in offline and online processing? Can we update the profile immediately after a new event? Can we expose the profile through a fast API? Can analyze and marketing team define new features and segments without waiting weeks for engineering? Can we monitor the whole process and understand cost at scale? These are the issues that determine whether a DMP becomes a real business platform or just another data engineering project that generates only cost and not business effect. Okay, so let's go to our event engine, how it works in practice. So when we talk about building a DMP in practice, the key point is integration. Company does not only need to build a data lake, stream processor, and feature store, and another model training tool, the API. It needs to use all these elements to work together as a one unified platform that marketing and data teams can actually use. This is where Algorithmics Event Engine is different from a generic cloud-based architecture. Event Engine is a fully integrated low-code platform. At the input level, Event Engine provides one endpoint for event delivery. Events can come from external sources. The event structure can be flexible and adapted to the business use case. Once event enter the platform, users can manage the logic in the graphic user interface. User can define metadata, event fields, validation rules, derived aggregates, time windows, and profile features instead of asking engineering team to code every aggregation from the scratch, and this can determine the logic in low-code interface. A major advantage is that the same platform supports both offline and online processing. We mentioned it before. Offline processing used to work with historical data to build models, create new machine learning models. Online processing is used to update the profiles on real time when new events arrive. So it helps avoid the common problem when features are defined one way for model training and one way for production. Event Engine also supports triggers. A trigger is a condition that decides when a profile should be evaluated by an ML model on when a specific decision should be made. For example, scoring can be triggered after a specific customer action. The platform also includes MLOps capabilities. User can define models, schedule a model building or retrain jobs, store models, monitor training runs, deploy models, and manage versions of models. This means that DMP is not only a profile database, it is a complete operational layer for profile-based machine learning and marketing decision. On the output side, Event Engine provides one endpoint for retrieving profiles and model scores. So the practical value is that the Event Engine reduces the complexity of building a real-time DMP. And this is the main value. Okay, let me show another view of the Event Engine architecture. As you see, we have these two loops, one for the online processing and another for model building, this offline mode. Both of modes are connected, both of processing pipelines are connected to the same event repository. They are repository with raw data collected by event engine. One definition of variables in the metadata database, and there is also integration with our automated machine learning tool, IBM. So let's imagine that we want to recreate the same setup, the same software in hyperscale environments, cloud environments. So let's see how complicated it may be. Here is the diagram of similar system built from the Azure Cloud Services. As you see, there we have a lot of services connected together. There's a huge effort to build custom integration code to recreate the same functionality. Of course, there's also a problem with latency and scalability of these solutions, but the main problem is the complexity of this solution. You need to use a lot of services connected together. The same situation is in Amazon Web Services. You can build such a solution from the ready-to-use generic services, but you need to connect a lot of the services and do a huge engineering work to make it working. And in Google Cloud Platform, the same situation, a lot of services to connect it together. So as you see, Event Engine is something that from the box you get a ready-to-use complete DMP without that you can set up without any effort, engineering work at the beginning. This is a huge investment, and of course it require constant monitoring and servicing. The cost also of running such a huge number of services may be extremely high when it is not set up properly. Okay, so let's go to live demo of Event Engine. I will show you how we can go from the raw data to audience segmentation and machine learning models. It will be very quick presentation because everything inside Event Engine is very simple. The process is very simple and straightforward. So let's switch to our demo. You can see now on the screen map of the New York City. This is New York City. We use data from New York City bike rentals system to show you how it works. This system provides publicly available feed with data about rentals and returns on every bike station in the New York City. So we can collect this data and feed our event engine and build profiles, in this case, that are built on the station level. So let's imagine that these bike stations are the same type of object like our customers in our internet shop or marketplace. In these badges, you see the predictions that are generated by Event Engine. In this case, we predict whether the station requires rebalance or no action in the next half an hour. So we use past data, information about the rentals and renewals, and some technical parameters of station, and also information about the time of the day to generate prediction about how many bikes will be rent and return in short time. Having the state of the station current, we can predict whether the team that maintain this bike station should rebalance station. As you see, it works very quick. And how it is defined? Events that are sent to Event Engine are two types of events. One type is or three types of event. One type of event is bike rentals. Another type of event is bike returns. And you have also event that send us technical information about station. We collect all of this data in Event Engine, and we have here a panel of Event Engine when we can define all elements required to build profile and models. At the first step, we need to define features or aggregates. So as you see, it is very simple. One line in this table is one aggregate, one feature, the profile. We need to name this feature, adjust this feature to the specific event type, show our Event Engine the field we need to aggregate in the event. So in the most of these events, we have time field because we aggregate over time something. In some cases, we get these technical features of the stations. As I click on the specific variable, you can see the settings of the variable. There is the definition of the field we need to use in aggregate. There is name. We also define type of the variable, type of the window that we use to aggregate, and type of aggregation. In this case, we count the events on the specific time span. We also define the information about how long is the time window we use to aggregate, whether the window is shifted or not, and so on. So there's a couple of parameters that you can use to aggregate data. We can also count data, sum data. We can calculate simple statistics. These are like maximum of some variables that are sent in the event, and based on it build basic variables. After that, we can build derived variables. Derived variables, there are variables that work on these basic variables. So, for example, here we have a variable net outflow that is simple difference between bikes, number of bikes that was returned and number of bikes that was rent. And here we have a simple formula to calculate this variable. Of course, it may be some complex formula. For example, here we have formula that generate us information whether the number of returns is rising or decreasing over the last couple of hours. So what we do, we simply adjust the parameters of the simple logistic regression to this time series of number of bytes that are returned. Okay, this is how we define these profiles, the variables in profile. Next step is to define predictive model based on this data. We can define variables that, for example, here arrival CNT tar is this variable that has target type. So this is a variable that is not defined as an aggregation of past data. This is aggregation of the future data. So this is only information from the model, how to build target data in offline mode. This is not something that is calculated on profile and return on profile. When we have this target variable defined, we can define a model. So here we have model defined. Here is model defined on this variable. The definition of model is also very simple. We simply choose a couple of options. The most important option is the time window we define for the target variables. So this is information how long in the future we want to predict our event, our target variable. So in this case, we predict in the time window with length 1 hour. Okay, so we have defined model. Another thing we need to define is trigger. Trigger is the definition of time point in which we need to calculate scores. We use a simple trigger that is also always true. So the meaning is that in every time point, we calculate the scores if the external systems want to retrieve scores. But we can, of course, define another, this in another way. Here is another trigger that activates scoring calculation only where on the specific station we have less than 10 bytes available. Okay, so this is definition of time when we calculate scores. We also defined the model and target variable. The last thing we need to define is the schedule the calculating, because we can schedule the building of these models. Typically, a system build models on a constant way, once a day, once an hour, and check automatically whether the new model is better than the build before and used in production. When the model is better, it is automatically deployed to production. So you can see here the schedulers. We can define the time period that the model is rebuilt. We can also define the quality criteria of the models. So in some cases, the models that are built are to have too bad quality to be deployed. So the system can automatically decide whether the model is good enough to deploy on production. In this case, we use simple statistical statistic that give us information about the model predictivity. The one means that model predict perfectly. Half means that the model predict randomly, and 0 means that model perfectly predicts on the opposite way. So in this case, we define that cutoff when the model is slightly better than random. Okay. So let's see runs. You can see the runs of the model building. And for example, here you see that we rejected some model because the quality of this model was too low to deploy. So as you see, sometimes it happens. So let's trigger the new run of the models. We can do it manually. So I can click a button to trigger model. There's a new task of model building, one shot. And we can look at the runs, and we can see that now systems start to preparing training data. After the data are prepared, they are sent to our AutoML module. And when the model is trained, it is evaluated and deployed if the quality is good enough. Let's go to the model that was built previously. I have linked to, you can see here, link to the model to the IBM platform that is designed for building automatic building model. And in this platform, you can evaluate the model. You can see the quality of the model, statistics of the quality. You can look at the variables that are used in the model. So all you require all necessary information to understand how this model works. Okay. So as you see, it takes some time to build model. Sometimes in our case, because we work on the quite a small data, it is built and generated quite quickly. But sometimes when we work on real-time use cases, when we connect our software to huge internet portals and we have thousands of events collected a second, it may take even a couple of hours to process this data and build model. This is not problem, but because typically we train model during some time intervals like 1 hour, like 1 day, 1 week. So it may. Oh, and as you see that the process started to build a new model. So we can go to the panel and see that there is new model in the running mode. Oh, it is built. So let's wait for the model deploying. So after a short time, this model will be deployed or not. That depends on the quality of this model. In this case, we have a good quality, so probably it will be evaluated as a good model. Okay. Yeah, model was deployed, and now algorithm recalculate user profiles. Why it recalculate user profiles? Because sometimes model can use variables that are not present in the defined in metadata, but not present in calculate user profile. So it requires to recalculate user states to have complete set of data to fit model. Of course, everything is versioned. You can build another version, add another variables, another models, and build another version of the profiles. And if there is necessary to switch to past versions, you can see that here at the bottom of the panel that we can host many profiles in one instance of the software. So we can build a lot of applications in one instance of the software. So let's go to the presentation to summarize what we saw in our presentation. Okay. So to sum up, so we have already discussed why first-party data is important, why building a DMP is difficult, and how Event Engine provides an integrated low-code platform for this type of architecture. So now let's summarize what you actually gain by using Event Engine. The first benefit is faster time to market. Building a real-time DMP from generic cloud components usually requires many separate services. Event Engine brings these capabilities together in one integrated platform with a graphic user interface that allows users to define and manage a large part of the logic in low-code way. The second benefit is real-time customer intelligence. In many marketing system, customer segments are uploaded in batches daily or in hours on after the campaign export. Event Engine is designed to update profiles and features as quick as a new event arrives. So these signals can be used while they still relevant. The third benefit is consistency between offline and online processing. There is no need to have separate data engineering team to prepare data for model building and another engineering team for deploying these models. Everything is in one place. So in many organizations, the features used to train model are created in one environment, while production features are implemented separately by engineering team. So this creates risk of inconsistency between its data. Event Engine helps to address this by supporting one feature logic across historical processing, live updates, and real-time scoring. The fourth benefit is lower engineering effort. Analysts and data teams can work in simple graphic user interface. This of course, does not eliminate engineering completely, but it reduces the number of cases where every new feature, segment, or scoring condition need to become a customer development task. And the fifth benefit is build whole mesh MLOps for marketing decision. Event Engine is not only about collecting events and creating profile, it also supports model definition, scheduling, training, retraining, model storage, deployment, versioning, publishing, and production management of the models. This allows companies to move from simple segmentation to predictive decisioning. You can define as many as you need predictive models and processes to retrain these models. And the sixth benefit is activation to API. I will show you how simple the API in Event Engine is. Let's switch to the screen. So if you look at asking about the predictive model scores, you can simply send identifier of the object we model, in this case station ID, and get scores from all these three models. The same about profile. You can quickly send query about the profile using this identifier and get all these variables in the form that are present now. So let's go to the presentation to sum up. Okay. And to sum up, from the performance perspective, the key point is that the Event Engine is designed for production scenarios where speed and freshness matter. We can process in Event Engine thousands of events a second. You can scale this software horizontally or vertically. There is no problem. And it updates profiles quickly, expose profile data with low latency, and of course support automated model building that its task very time and resource consuming itself. But in event engine, everything is optimized to work as quick as possible and as cheap as possible. The main takeaway is that the event engine gives companies a practical way to operationalize first-party data. It helps move from raw events to profiles, features, calls, and automated decision in one low-code platform. And this is everything I wanted to show you. If you want to ask any question, we are ready to answer it, and let's discuss.